Hello everyone, you're welcome to solve this nice algebra problem. For any returning subscriber, thank you so much for coming back to watch videos from this channel. And if it is your first time you come across videos from this channel, please like and subscribe and hit that subscription button so that you can get notified whenever I upload new videos. Now, solution from here, we have that m cubed plus 5m, this is equal to 42. Now, from here, let's take 42 on the left-hand side so that we'll have m to the power 3 plus 5m subtract 42. This is equal to 0. Now, here we have m to the power 3 plus 5m subtract 42, which we can express as 27 plus 15. This is equal to 0. The next step from here, we have m to the power 3 plus 5m subtract 27. We can express 27 as 3 to the power 3. Subtract 15. This is equal to 0. Now we have m to the power 3 and 3 to the power 3. So we can write this as m to the power 3 subtract 3 to the power 3 plus 5m subtract 15. We can express 15 as 5 multiplied by 3. This is equal to 0. The next step from here, this is m to the power 3 subtract 3 to the power 3 plus, now here we have, this is the same thing as 5 times m subtract 5 times 3. This is equal to 0. Now we have m to the power 3 subtract 3 to the power 3 plus, now here we have 5 and 5 is common here. So we can factor out 5 so that we'll have 5 into the bracket here. M subtract 3, this is equal to 0. Now from what we have here, this is the difference of two cubes expressed as a cube minus b cubed, which we can express as a minus b, a squared plus ab plus b squared. And therefore, m to the power 3 subtract 3 to the power 3. This can be expressed as m minus 3, m squared plus 3m plus 3 squared, which is equal to 9. Substituting this, we'll have m subtract 3, m squared plus 3m plus 9 plus 5 into the bracket m minus 3. This is equal to 0. The next step here, m minus 3 and m minus 3 is common. So we factor out m minus 3. So that here we'll have m squared plus 3m plus 9 plus 5, close the bracket, this is equal to 0. Now this implies that we have two parts here. We have m minus 3, this is equal to 0. And we have m squared plus 3m plus, this is 9 plus 5, which is equal to 14. This is equal to 0. Let's proceed. Now here we have two parts. The first part here, the first value of m, we have m1. This is equal to 3. Let's solve for the other values of m in this quadratic equation, which is in the form of am squared plus bm plus c. This is equal to 0. Now, a from this quadratic equation is 1, b is equal to 3, and c is equal to 14. So let's take the nature of this quadratic equation by determining the discriminant value, which is b squared minus 4ac Substituting this is 3 squared, subtract 4 times a, which is 1, times c, which is 14. So in this case, 3 squared, this is 9, subtract 14 times 4, this is 56. We have 56. So we have 9, subtract 56, and this is minus 47, which is less than 0. And this implies that we have two complex roots here. We have two complex roots. And so for these two complex roots, that is m2 and m3, we apply the quadratic formula, which is minus b plus or minus the square root of b squared minus 4ac divided by 2 times a. Now let's substitute the values of a, b, and c. So here we'll have minus 3 plus or minus the square root of b squared minus 4ac, which is the discriminant value here, which is minus 47 divided by 2 times 1. So here, this means we have negative 3 plus or minus. We can express negative 47 as 47 times minus 1, or this divided by 2. So here we'll have negative 3 plus or minus. Now, the square root of negative 1, this is I, then square root of 47 divided by 2. So this implies that m2, m3, this is equal to minus 3 plus or minus I square root of 47 over 2. Specifically, m2 is equal to minus 3 plus I square root of 47 divided by 2. And m3, this is equal to negative 3 subtract I square root of 47 divided by 2. Now, these are the two complex roots that we have, or the two complex solutions that we have. And given that we have only one real solution here, that is m1 is equal to 3. This is the real solution that we have. So let's verify this quickly. Let's verify. Now, if you recall, we end that m to power 3 plus 5m, this should give us a value of 42. Substituting the value of m, which is 3, we'll have 3 to power 3 plus 5 times 3. This should give us a value of 42. And therefore, 3 to power 3, this is 27 plus 5 times 3, and this is equal to 15. This should give us a value of 42. And it's true that 27 plus 15, this is 42, which is equal to 42. And that implies that the left hand side is equal to the right hand side. And that satisfies the condition. So we have 3 solutions to this algebra problem. Thank you for watching, and kindly subscribe. Please subscribe, my good people. See you in the next video. Bye bye.